Hi, welcome to Light Tutelage. In this session, I will discuss how to calculate number of protons, number of electrons, and number of neutrons in an isotope. Let me take one example here. Let's say an isotope of uranium is given here. At the top, we have the number 238, and at the bottom, we have 92. This is an isotope of uranium. The top numbers represents the mass numbers. It is the mass numbers, and the number which is given at the bottom, that is atomic numbers. From these two data, we calculate the number of protons, number of electrons, and number of neutrons in an isotope of this uranium. Let me calculate number of proton first. Well, the atomic numbers of this isotope is given, that is 92, and so we know that atomic numbers represents the number of protons in an atom. Since the atomic number is 92, number of protons are also 92. Now let me calculate number of electrons. This is an isotope of a neutral atom, and we know that the number of protons are equal to number of electrons in a neutral atom. Since the protons number are 92, number of electrons will also be 92. Now, here you can see that mass number of uranium is given, that is 238, and now we calculate number of neutrons in this isotope of uranium. We apply the following formula to calculate number of neutrons. The formula is, that is mass numbers, m is equal to number of protons plus number of neutrons. Neutron does not carry any charge. Now the mass number is known, that is 238. I plug in the value, that is 238 is equal to protons. Number of protons we have already determined, that is 92, and here we have unknown neutrons. Now we can do the calculation to calculate number of neutrons. I subtract 92 on both sides, and these will cancel out. 8 minus 2 is equal to 6, and here we have 3 minus 9, and 3 is smaller than 9, that's why 1 is taken from 2, it becomes 13. 13 minus 9 is equal to 4, and here we have 1. These are the number of neutrons. Number of protons are 92, number of electrons are 92, and number of neutrons are 146 in this isotope of uranium. Let me take one more example, that is an isotope of bismuth, and its symbol is Bi. The number which it has at the top, that is 210, and at the bottom the number it has, that is 84. At the bottom it represents the mass numbers, and at the top which it represents the mass number, and at the bottom the number which is given, that is atomic number. And from these two data we calculate the number of protons, number of electrons, and number of neutrons. We follow the same method. Let me take number of proton first. The atomic number is given 84, and we know that atomic number represents the number of protons in an atom. Since the atomic number is 84, the number of protons are also 84. And let me take number of electrons. The number of electrons are equal to number of protons in a neutral atom. This is an isotope of bismuth, that is a neutral atom. And so since the number of protons are 84, the number of electrons will also be 84. The mass number is given, that is 210, and so we calculate the number of neutrons. We apply the following formula, that is here we have mass numbers, m is equal to number of protons plus number of neutrons. Mass number is known, that is 210. And here we put number of protons that we have already calculated, that is 84. I put here 84 plus number of neutrons. Number of neutrons, it is unknown. Now we can do the calculation over here. We subtract 84 on both sides. Well, here we have 0, 0 minus 4, 0 is smaller than 4, that's why 1 is taken from 1, it becomes 0. Here we have 10, 10 minus 4 is equal to 6. And now at the top we have 20, and say at the bottom we have 8. 20 minus 8 is equal to 12. These are the number of neutrons. The number of protons are 84, number of electrons are also 84, and number of neutrons are 126. Let me take the last example, that is from radium, and the symbol of radium is Ra. Here we have Ra. The number which is given at the top, that is 222, and at the bottom, that is 88. The top numbers represents the mass numbers, and at the bottom, the number which is given, it is atomic numbers. And from these two data, we calculate the number of protons, number of electrons, and number of neutrons. Let me take number of protons at first. Here we have number of protons. The atomic number is given 88. That's why number of protons are also 88. And now next is number of electrons. Well, the number of electrons are equal to number of protons in a neutral atom. Since the number of protons are 88, that's why number of electrons are also 88. Here we have 88. Now the final thing that we are going to discuss, that is we are going to calculate, that is number of neutrons. And so mass number is given 222, and we apply the formula, that is mass numbers, m is equal to number of protons plus number of neutrons. Sorry, it is having zero charge. Now we can plug in the value, that is 222, that is the mass number. I plug in the value, and the number of protons, that is we have calculated already, that is 88. Here we have 88, and number of neutrons, it is unknown to be calculated. Now we can do the subtraction of 88 on both sides. Here we subtract, we cancel it. Now we do the subtraction. Here it is 2, and 2 is smaller than 8. That's why 1 is taken from 2. It becomes 12. 12 minus 8 is equal to 4. And here we have 1, and 1 is smaller than 8. That's why 1 is taken from 2. It becomes 1. And here we have 11. 11 minus 8 is equal to 3. And here we have 1. And these are the number of neutrons. The number of protons are 88. Number of electrons are also 88. And number of neutrons are 134 in this isotope of radium.